So like I said, 12 questions. Starts pretty easy with the combination stuff, the different combinations. So how many different ways can you form the 5 committees? So on this one, you just count how much is in each category and multiply all of them. So we're going to do 3 times, what was that? 1, 2, 3, 4, 5 times, 5 times. 1, 2, 3, 4, 5. My goodness, why is it not? 1, 2, 3, so times 3. 3, 5, 5, 3, and then 2. So anytime you're trying to figure out all the possible combinations, you just multiply how many you have in each category, and it will give you your answer. 450. All right. The next one is permutation and combination. Yeah, this is a good one to do. Okay, so permutation, the order matters. Combination, the order does not matter. You're going to have to just use common sense to decide which one on this one. And be careful because there's different variations of this problem. So you have an A and a B. Sometimes it's 1 permutation and 1 combination. Other times it's 2 combinations or 2 permutations. So don't think that you're going to use one of each on each one, okay? Permutation where the order matters. So this one says password, the order matters when you type in a password. A race, so if you get, like, I think it does gold, silver, bronze, like the order matters because gold's better than silver, better than bronze. President, vice president, treasurer. President's better than vice president, better than secretary or treasurer, whatever. So the order matters on those. If there's another race like first, second, third, that the order matters. The weird one is travel. Travel, the order does matter. And then the other one that we did in my 8 a.m. Sales, it is ranking the top 5 and it says in order of effectiveness. So it kind of says the word order in there, but the order matters on that one, okay? So those are the ones that I can think of off the top of my head where the order matters, but you just have to use common sense, like does the order matter? So in this password, or in this one, it says no letter may be repeated. That's kind of the big thing where the order matters. Only lowercase can be used, so you have 27. So you have the 2 buttons on the calculator. Again, permutation, order matters. Combination, it does not matter. So I click permutation. There's 26 letters in the alphabet. Oh my goodness. 26. And it's a 5-letter password. So you do 26 permutation 5 because the order matters. And you get your answer 7893600. Okay. The next one, it says from a collection of 50 store customers, 3 are chosen to receive a special gift. How many groups of 3 can you create? So this is going to be 50, choose 3. The order's not going to matter on this one. It doesn't say like somebody's going to get a better gift than somebody else. There's not like a first place gift, a second place gift. So it's just you're picking a group of 3 to win. So 50, choose 3 would be 19,600. All right, number 3 goes into probability. So it's talking about the sample space. The sample space is all the possible outcomes. So you got a number cube that's labeled from 1 to 6. So all the possible, you could roll it and get a 1, a 2, a 3, a 4, a 5, or a 6. So the sample space is all the possible outcomes. And then the event is what you're looking at. So what could you get if you want a number less than 5? I'd get a 1, 2, 3, 4. So I know y'all think about this through your head, but this is what you're doing. If I said, what's the probability of getting a number less than 5? In your head, you say, okay, I can get a 1, 2, 3, or 4. That's 4 options out of the 6 total. So 4 out of 6 would be the probability. So sample space is all the options. And then the event is the specific thing we're looking at. Number 4 is the easy probability one. We did get a weird one last class, so I'll talk about that in a second. But 12 equally sized slices, 4 yellow, 3 blue, 5 red. What's the probability that the dial stops on a yellow? So probability is always what we're looking at. Here it's the yellow. There's 4 of them, and then there are 12 total. And you do not have to reduce the fractions. It will count it right if you don't reduce the fractions. The weird one we got last class was all the slices were yellow. And then it said, what's the probability you land on a yellow? Well, it would be 1, or it was like 8 out of 8, or in this scenario, 12 out of 12. Either of those answers would work. I believe there's also a variation where it would be like if they're all yellow, and it'll say, what's the probability you land on a red? And it would be a 0. So you can get 0 and 1 for this because those are probabilities always between 0 and 1. Deck of cards they tell you there's 52 right here, and then you just got to look at it. A face card, so what's the probability you get a face card? So there are 12 face cards right here in the gray. So that'd be 12 out of 52. Again, you don't have to reduce down the fraction. What's the probability you draw a club? The club is, you can look at this 2 different ways. You can count them. So there's 13 out of 52. Or you could say there are 4 suits, heart, diamond, spades, clubs. So it'd be 1 out of 4 that you get a club, which 13 out of 52 reduces down to 1 out of 4. What's the probability you draw a face card or a club? You could do the formula where you add these up and then subtract the ones that overlap. Like if I do face cards is 12 plus club is 13, that's 25, right? But the issue with that is when I add up the face cards and then I add up the clubs, I've added these 3 twice. So my answer really should be 22. I think with this chart, most of y'all will probably say, okay, there's 12 face cards. I've already counted these 3, so then that leaves me 10 other cards. So 12 plus these 10 right here would be 22. So you can kind of just count all of them instead of use the formula. This one is the experimental versus theoretical. You have experimental first. The experiment is you run an experiment and see what the probability is. Theoretical is using math to figure out what the probability is. So the probability of rolling a 2 based on the experiment, she got 28 out of 200. It tells me up here 200 twos. So that would be 0.14. But the theoretical probability of getting a 2, there's 6 options. There's 1, 2, so that would be 1 out of 6, which would be 0.167. Okay. So this answer always has something to do with, it's called the law of large numbers. The more that you do it, the closer and closer these numbers are going to get together. So we would say something like, as the numbers increase, as the number of rolls increase, we expect the experimental and theoretical to become closer. Okay. So 200s, she did it a lot of times, so they're kind of close. But if she'd have done it 2,000 times, they'd be really close. So the more and more you do it, the more and more these numbers are going to start to become equal. That's kind of what you answer on part C. Number 7 is talking about the union and intersection. So let me write this one out, actually. Why not? So on number 7, event A is, you got a 1 through 6. So event A is an even. So if you want to write those out, it doesn't hurt. I guess 1's not even. 2, 4, and 6. And then the number rolled is less than 4 is B. So that's 1, 2, 3. Okay. The and, so and means to share. It's what they share. So you just look, if you write them out, it makes it so much easier just to look up there and see it instead of trying to think through it. But what you're doing is, what is an even and less than 4? The only thing that they share is a 2. Okay. Or is the union, the way I think about it is you bring them together. So you're looking at what is even or less than 4. So you would actually do even would be 2, 4, 6. And then less than 4 would be 1, 2, with 2 is already in there. I don't think you have to write them in order when you put them in ALEKS, so that should work. But the or is always what you bring together. What is even or less than 4? So it's a combination. It's union you bring together, marriage. And then and is the share. And then the complement of B, this is the not, what's not in B. So if B is 1, 2, 3, the not B would be 4, 5, 6. Okay. I will say, because I did this last class, be careful on this one because I assumed that it was like 1 through 6, but the last class said a marble, not a cube, and it was 1 through 8. So, like, make sure you look at that real quick to know your total amount there. All right. Number 8. What is the probability that the dart lands on a slice with a number greater than 4? So, I guess we just need to calculate. Oh, no, we can do a fraction. A number greater than 4. So, that could just be a 5 or a 6. We're not including 4, so it'd be 2 out of 6. Okay. The next one is a conditional probability. So it says, what's the probability that the dart lands on a slice with a number greater than 4, given that it lands on a white slice? Okay, so you glance down and you notice that it's white. That means you only have 4 options instead of all 6 options. You know it's not going to be one of the gray ones. So now out of those white slices, what's the probability you get a number greater than 4? You again have 2 that are greater than 4, the 5 and the 6, because they're both white. But you're taking it out of 4. So anytime you see that word given, it kind of changes your total amount. Since it says given that it lands on a white slice, I'm only looking at the white slices, and there's 4 of them. So now I say, okay, what's the greater than 4 out of those white slices? On a chart here, I'll walk through this. I'll come back and do the answers in just a second, but probability of a cat. So the probability of a cat would be these two, right? So 12 plus 8 would be 20. So that would be 20 out of the 80 total. So 20 out of 80. I guess I can probably do that. That's 0.25. And then the vaccine and a cat would just be this number. It would just be the 12. Okay, so 12 out of 80. I don't know if I can do that. 6 out of 43 out of 20. So 0.15. Okay, the next one is the reason a vaccine given. This line right here means given that it's a cat. So I'm going to only focus on the cats. That means I'm only looking at this row. I am not paying attention to this row at all. Okay, I don't even look at that row. So I'm only looking at the cat row because it says given that we're a cat down here. It says given that it's a cat, so I already know it's a cat. I'm only looking at the row that focuses on, or the column that focuses on. So now I look at the vaccines out of those cats. Well, we know there's 20 cats, so I do the vaccines out of the cats. Okay, so that would be 0.6, and that should be my answer. I believe they might even show you, I don't know on the explanation, I should probably look, you could just do part B divided by part A, and that would also give you the answer, but that's talking about the formula, and I don't really do the formula because I want you to think through it. But either way, you can do that. Again, though, this line right here means given that it's a cat means I'm only looking at that row. Another chart. This one, for some reason, does not have a calculator on it. I've got to email the Alex people. I was going to do that in between classes, and I forgot. All right, so what's the probability that you pass the test? Probability they pass the test would just be these right here. So 41 plus 39 is 80. And then 80 out of 125 would be my answer for this one. I'll do it in my calculator real quick just to write it down. 80 divided by 125 is 0.64. And now the second one is a conditional probability as well. What's the probability that they passed given that they took the class? So when we see that given, we only look at that row right there, and that's all we're looking at. So we're trying to see if this class was worthwhile or not. 21 plus 39 is 60. So given that they passed the test would be 39 out of 60. What did I just do? 39 out of 60. Okay. And when I do that in the calculator, I get 0.65. My goodness, I can't write today, apparently. So given that they took the class means I'm only looking at that row right there, and I do the passed out of the class, out of the people that took the class. All right, since these numbers right here are pretty much the same, right, 64 and 65, is it worth the money and the time to go take the class? Not really, because the people out of the whole group, it was 64%, and the people that took the class, only 65%. So since they are about the same, that's going to be the bottom answer. Since the probabilities are about the same, we're saying that it's probably, is there evidence that a teenager who takes the class is more likely to pass the test? Not really. So it's not really worth it to take the class. Just go take the test because you got about the same chance of passing. Oh wait, we did that one. Yeah, this goes fast. Yeah, sure. I'll write this one out too. Another chart one. Kind of wish they gave you the total amounts. Okay, what's the probability that a resident owns a car and lives alone? So this is the and. Car and lives alone would be 6 out of 137. Okay. The next one is or. What's the probability that they own a car or live alone? So that or changes things a little bit. Or means to add. I honestly think when y'all do this in Alex, it's probably easier not to do the formula. But the cars, so like if I was doing the formula, I'd say, okay, the cars is 39. Alone is 33. So if I do 39 plus 33, I would get 72. But the problem is with that is I added 6 twice. So it would be 72 minus 6 would be 66. Okay. Honestly, I think that so my answer is 66 out of 137. Honestly, with the chart and they don't give you the total amounts, I'll show you kind of what I would do in the calculator. If I was in your spot, I'd probably say, okay, what's the probability they own a car or live alone? I'd say, okay, car is 66 plus 33. Alone is 6 and 17, but I already have the 6 in there, so just add the 17. Don't worry about the 6. Yes.
17 plus 6, 23?
What did I put, 33? Yeah, adding is hard. I think I put 33. Sorry, yeah, so that's the wrong answer. The right answer is 56, not 66. So it's 56 out of 137. So don't forget to divide it by the end. So my bad, I added wrong, but the process was right. So yes, that is kind of what I would do. I'd say, okay, car 6 plus 33. And then I already added the 6 under alone, so just add the 17. Like, it's probably easier to not do the formula on this one as well. Like I said, if you do it the other way, you would say, okay, car is 39, alone is 23, but then I added the 6 twice. I think that's probably harder than the way that I did it previously. So there's the correct way, yeah. And then the last one is another one of these. What is the probability that the customer was new or took a boxing class? So new is 34 plus 11 plus 33 plus 24. And then boxing is 33 and 5, but I already added that 33 in there, so I'm just going to add the 5. Makes sense? I think it's probably easier to do it that way than the formula. And then I divide that by 184. So I get my answer of 0.582. I think it's just... Then the next one, what's the probability that the customer took a yoga class given that the customer was not new? Okay, so not new means I'm only looking at the not new row. So we need to total that up real quick. 23 plus 36 plus 5 plus 18. So I'm only doing it out of those 82 people because I'm only looking at the not new row. So now I say, what's the probability they get the yoga out of the not new? Oh, man, what was my answer? 82. Okay, yoga out of not new would be 23, yoga not new, divided by the 82 that are in the not new. And that would be my answer. So again, what I'm looking at, I'm just looking at this right here. Oh, no. No. So this is 82, right? So I just do the new out of that, 23 out of 82. And that is the 12 questions on the test. I told you it wouldn't take very long.